In this video, I'm going to show you how to download data from the CDEC website using the cder package in R. So CDEC stands for California Data Exchange Center, and it's a resource that's managed by the California Department of Water Resources and brings together a lot of data collected from throughout the state of California and puts it into one convenient place. So first we're going to look at how to look up stations, and so I'm going to look at the station locator map, and I've already got that loaded. So this provides a GIS interface in order to look up sites where data is collected and get the information about what data is collected at that site. So I'm going to use the Rough and Ready Island site in Stockton, California, and it pops right up. And this is a good site to use because there's a lot of data that's collected at this site. It has a continuous monitor. And so if I go here, then I can see the lat long for that site and also the list of parameters that are measured at this site. I can also get more information by looking at the site here. And this is also convenient because in addition to having a list of sensors that are located at this monitoring site, it also has the sensor numbers that we're going to use when we query the database. Okay, so let's go over to R. And I've set up an example to show you how to use the cder package. And so let's go ahead and load the tidyverse packages because I'm going to use those in order to clean up the data set and visualize it, and also the cder package. Okay. So first what I need to do is to define which parameters I want to get from the database. And if we need to look up the station data, we can actually do that from R using this CDEC meta function. But we've already looked at the site, so we'll go ahead and define the station that we want to look at. The sensors, so I'm going to get data for solar radiation, chlorophyll, dissolved oxygen, pH, and electrical conductivity. So I establish the sensors using a vector in R, and I'm going to get data that's considered to be event, which is the continuous 15-minute data. So they have continuous monitoring at this station, and they collect the data every 15 minutes. I'm going to collect data for 2021, so define the start and end dates, and then in a single line I can query the database and get the data for the Rough and Ready Island station. Since it is 15-minute data collected over a year, it's going to take a minute to load, and there it is. Okay, so let's go ahead and take a look at that data. So I can see that it has some of the information that I queried in this data set, and it has the dates. And a nice thing about the tidyverse is that when I read in the data, it correctly formatted the date timestamp so that I don't have to do anything to format the date. It's already formatted correctly. And then I've got the values here. So those are kind of the important things. Also the sensor type. Okay, so I'm going to go ahead and create a little summary table to look at that data. And I'm using the summarize function in R, and also the drop NA so that all the summary statistics are calculated properly. So here I've got a summary statistics table by parameter, calculated the mean, median, standard deviation, min and max. And then I'm going to create a visualization of the data using ggplot. And I'm using geomepoint because I'm going to create scatter plots. And I'm going to use the facet wrap function in order to plot all the parameters on separate plots. So go ahead and run that. And I also have the code in here to save it to a PNG file, which is kind of nice if you're going to be putting it into a report or something like that. And it's just taking a minute because the 15-minute data is pretty intensive. And there is a warning message that it eliminated the rows with the missing data. Okay, so it plotted the data here. And here's the data plotted. So I have the chlorophyll measurements, the dissolved oxygen, electrical conductivity, pH, and the solar radiation data all plotted together using the facet wrap function in R.